Swagatam Kapati Mathematics classes. Guru Bhyo Namaha. This is your Murali Krishna. This is the 12th video on the chapter Trigonometry. Now, in this video, I am going to discuss about the trigonometrical ratios of sum and difference of two angles. Of course, we can have two or more angles also. Now, the same chapter is famous with another name also, compound angles. What is the compound angle? Very simple. Let A, B, C are any angles. Of course, you can take one more also. I can from the three. A, B, C are any angles. Now this A plus B is a compound angle of A and B. A plus B plus C, compound angle of A, B, C. Of course, you can have A minus B also. Of course, you can have A plus B minus C. So all possible linear combinations of these ABC angles is called the compound angle. Now, in this chapter, what I am going to discuss, I am going to find the value of trigonometric ratio for this A plus B. That means, say for example, sine of A plus B. I am going to express the sine function of A plus B in terms of sine and cos functions of A and B individually. So, in this case, we have some identities. In this lesson, I am going to prove those identities first. What are the identities I am going to do? Let me make a list of all the identities first. If you are interested, you can learn the proof, otherwise you can skip. But if you are preparing for any international examination like IIT mains and advanced level, or like any MIT entrance examination, the proofs are very, very important. Here, proofs are very, very important means not in examination point of view. If you will learn the proofs, the proof involves a lot of logic. How the proof is developed. If you know that one, and cracking a numerical question is very easy. Yes. Now, let me make a list of identities. Sine of A plus B is equal to sine A cos B plus cos A sin B. Sine of A minus B is equal to and of course we have part of A plus B, part of A plus B also. Now my advice is, if you are only confirmed the board level, don't break your head in learning the proofs. Just memorize the identities you can. But if you are looking beyond that board examination level, yes, definitely you have to learn the proofs. Okay. Now I will prove one by one. First proof is identities. Sine of A plus B is equal to sine A cos B plus cos A cos. Now you may get one doubt. All these angles, all these identities are true for any size of an angles or any sign of the angles? Yes. In the place of A and B, you can take acute angle, obtuse angle, reflex angle, any angle you can take, but these are the proof. So I can say for all A and B, any size here, A and B are of any size and any sign. Yes. Let me prove one by one. For all a comma b, we have sin of a plus b is equal to sin a cos b plus cos a sin b. Now, to prove this one, I am going to take help of plane geometry. Okay. First, let OA is any initial line. OA rotates to OB. To make an angle, say for example, OB further moves an angle, move to C to make an angle, say for example, B. Therefore, angle AOB angle is equal to A and angle BOC is equal to angle B. Of course, angle AOC is equal to A plus B. Okay. Now, let point P, let P be any point on OC. From point P, first number one, draw perpendicular lines to first OA, then OB. Let this equal to M is equal to M. PM and PM are perpendiculars drawn from P to OA and OB respectively. Then what I do, I draw a line perpendicular to PM. Let's say this one. Let's say, and one more, I am drawing perpendicular line from N to, I will go on. I write this as. Let OA is the initial line. OA rotates an angle. Say OA rotates to OB. Let this angle is equal to A. And OB further rotates to say C. And this angle is equal to B. Therefore, we have angle AOB is equal to A, angle BOC is equal to B. Of course, A and B, A plus B, angle AOC is equal to A plus B. Next one, I will take a point P on OC. From P, I will draw perpendicular lines to OA as well as OB. Let this name as, say for example, M, and this is equal to Q. let P be any point on OC. PM and PQ are perpendiculars drawn from P to OM to OA and OB. Next one, from point Q, I will draw perpendicular line to OA. Let's say this is equal to N, and from Q one more perpendicular line. Let's say this is equal to R. So from Q, perpendiculars are drawn to OA and MB. Second point is QN and QR are perpendiculars drawn from Q to OA and M respectively. So, construction part is over. Now, look carefully. This is angle A. Since RQ is parallel to MM, this angle also will become A. Since PQO is 90 degrees, then this angle will become 90 minus A. Now, this again a right angle. Since it is 90 minus A, this angle is equal to A. So, let's take it carefully. Now, angle, start from here. RQA is equal to angle AOB is equal to A. How? It is alternate angles. Therefore, angle PQR is equal to 90 minus A. Therefore, angle RPQ is also A. Therefore, in triangle PQR, angle P is equal to A. Yes. So the construction part is over. Now, first of all, I consider the triangle OMP, and I take this angle A plus B. For this A plus B, PM is opposite side and OP is hypotenuse. Therefore, from triangle OMP, sine of A plus B is equal to PM by OP. Now I do some little the manipulation to get my answer. So this is, we have PM by OP. Now my PM is from here. I can write as sum of these two. So my MP is equal to MR plus RP. I am going to write one is equal to MR plus RP by OP. Then I will split into two fractions, MR by OP plus RP by OP. Now, but my MR is equal to QN. My MR is equal to QN. I can do that one. So what I do is equal to MR is equal to QN. QN by OP plus, of course, I don't touch RP by OP. Now here, what I am doing, QN is the opposite side for an angle A. If I can have QN by OQ, I can write as sin A. So what I do here, I do a simple manipulation, ON by OQ times of OQ by OP. This part I do. Next one, I have RP. RP is adjacent side to angle A here. If I have PB, I can express in cos A. So what I do, PQ. What I do, RP by PQ times PQ by OP. I here divided, multiply OQ, here PQ and PQ. Now very simple, that is equal to number 1. QN by OQ. QN by OQ is equal to cos A. So that is equal to 1. We have from triangle ONQ, sin A is equal to QN by OQ. Next one, OQ by OP. Where is OQ? Oh, very good. OQ by OP. From triangle OQP. From triangle OQP. OQ by, and what is this one OQ by? OQ is equal to adjacent side and is equal to opposite hypotenuse. Cos B is equal to OQ by OP. Next one, RP by PQ. Where is RP? Here RP. RP by PQ. From the triangle PQR. RP is this one. So cos A is equal to small letters in triangle, from triangle ONQ, we have sin A is equal to QN opposite side by hypotenuse. From triangle OPQ, cos B is equal to OQ by OB. From triangle PQR, where is PQR, cos A is equal to RP by PQ. And in triangle OPQ, finally sin B is equal to PQ by OP. Let all these are 2. Now substitute 2 in 1. Put 2 in 1. We get sin of A plus B is equal to sin A cos B plus cos A sin B. The next identity is cos of A plus B is equal to cos A cos B minus sin A sin B. Now the diagram is same, construction is same as sin of A plus B. First one, from triangle OMP, from triangle OMP, cos of A plus B is equal. What is adjacent side? OM by OB. Method is same. OM. Now by OM can be written as ON minus MN. That is right. Is equal to ON minus MN by O. Method is same. Now split into 2 fractions. ON by OP minus MN by OP. Now I want to involve this triangle. So what I do, I can write MN is equal to QR. That part I do is equal to ON by OP minus QR by same OP. That's all. Now ON, I have here ON. If I have ON by OQ, I can write cos A. So what I do, I multiply divide by OQ here. ON by OQ, operation is same, times of OQ by OQ minus QR. Where is QR? This is QR. Now I want, this is QR, this is. If I have QR by PQ, I can write sin A. So what I do, I multiply, divide by PQ. QR by PQ times PQ by OP. Operations are same. Now, very simple, ON by OQ. ON by OQ is nothing but cos A. So here, times OQ by OP. OQ by OP is nothing but cos B. Minus QR, where is QR? Yes, this is QR. QR by PQ is nothing but sin A. Times PQ by OP, where is PQ? PQ by OP is sin A. We got the answer. Therefore, cos of A plus B is equal to cos A cos B minus sin A sin B. Once you know how to do sin of A plus B, cos of A plus B becomes very easy. Now, yeah, please note it. Sin of A minus B. Sin of A minus B is nothing but sin A cos B minus cos A sin B. How? Very simple. We know that I can write it as sin A plus minus B. Now I apply my sin of A plus B formula. This can be written as sin A cos of minus B plus cos A sin of minus B. And you know very well, cos of minus B is equal to plus cos B. Sin of minus B is equal to minus sin B. So put cos of minus B is equal to cos B and sin of minus B is equal to minus sin B. Hence my formula will become sin A cos B minus cos A sin B. Similarly, you can do cos of A minus B also. Similarly, cos of A minus B is equal to cos A cos B plus sin A sin B. Now, let me prove next one, tan of A plus B. Tan of A plus B is equal to, again we have tan A, tan B, tan A plus tan B by 1 minus tan A, tan B. For this one, consider tan of A plus B is equal to sin of A plus B upon cos of A plus B. And I apply the formula sin A cos B plus cos A sin B upon cos A cos B minus sin A sin B. What I do, I divide both the numerator and denominator, dividing both numerator and the denominator by cos A cos B. If I do so, we get sin A cos B by cos A cos B plus cos A sin B by cos A cos B or cos A cos B by cos A cos B minus sin A sin B by cos A cos B. Now convert into, I can do one thing, I can cancel this cos B and cos B, cos A and cos A, cos A cos B cancel. After doing so, I get sin A by cos A is nothing but tan A. Of course, this is tan B by 1 minus tan A tan B. Now the next one. Similarly, I can write tan of A minus B. Same technique, but I am not proving, just I am making the list. Tan A, tan B by 1 plus tan A B and cot of A minus B also. Cot of A plus B is equal to cot A cot B minus 1 by cot B plus cot A. And finally, cot of A minus B is equal to cot A cot B plus 1 by cot B minus cot B. So we have for sin 2 formula, for cos 2 formula, for tan 2 formula, for cot 2 formula. Totally 8 formulas are there. Please try to memorize this.